Okay, this one will take a little bit longer. We've got practice problem number 8, so turn to page 236 with me. The problem says a chemist reacts 50.0 milliliters of a 4.5 molarity of carbonic acid with excess potassium hydroxide. How many grams of potassium carbonate are produced? Okay, we have to start off by writing the problem. Okay, so the first thing, the equation, So we have carbonic acid, which is H2CO3. Okay, obviously this is our acid. Okay, H2CO3 with excess potassium hydroxide, which is going to be KOH. Okay, do y'all see that the OH is in there? That is our ionic base. Okay, let's make sure that these are written correctly. Yes, it is. It doesn't need to be changed. What does that create from the problems we learned earlier? It creates water and a salt. What is the salt that we have? Once this is gone and this is gone to make the waters, we have KCO3. Okay, the K is a positive and CO3 is a 2 negative. Okay. Got to make sure this is balanced. It's not. We're going to need a 2 here. Okay, so now with the balancing, we've got to make sure it's balanced. Look here, we have 2 hydrogens. We have 1 hydroxide. Okay, we're going to need 2 of these, and that's going to make 2 waters. Okay, so now we have a balanced equation. So now we can move on. Okay, so we now know that we have 50.0 milliliters of a 4.5 molarity carbonic acid. Okay, and so I like to kind of write my stuff up there. It just helps me. So I have 50.0 milliliters. Okay, I'm going to erase this. Sorry. Okay, and it is 4.5 molarity. Okay, and my question is, how many grams of potassium carbonate are produced? And that is this over here. Okay, so this is what I'm going to try to find out. I have this information and I'm going to try to get over there. Okay, so with what I have molarity and I have milliliters. Okay, so how in the world, what can I do? Remember, the whole point of stoichiometry is the fact that I can relate in moles. Well, how in the world am I going to get in moles here? How can I do this? Okay, now if you remember, we have our molarity equation. Molarity equals number of moles over number of liters. Okay, so we can use this. Okay, now we don't have liters, we have milliliters, so let's change this. You know how to do that, so I'm just going to tell you what the answer is, and it is 0.05 00 liters. Okay, so that is liters. Here we go. So with our looking at this formula here, and remember I told you always look, what do I have and what do I do with that information? Okay, so this is, I have molarity and I have liters, so I can find out the number of moles. Okay, so I'm going to take the little thing I have there. So my molarity, 4.5 molarity equals how many, the number of moles. I guess I'll write number of moles. Okay, over, and I know the liters is 0.0500 liters. Okay, so if I change that around, okay, and so again, we're to the algebra. If I want to know what this is, I'd multiply these two together. Okay, and so my number of moles is, look at my chart, is 0. I have to have two significant figures, 23 moles of H2CO3. Okay, what do I do next, guys? What do I do next? I have moles of this. I want to relate it to this. Because you have a balanced equation, you should be able to figure this out. It's coming from last chapter. We have 1 mole of H2CO3 that is equal to 1 mole of K2CO3. Okay, and so I would write that out. Now I know it's 1 mole over 1 mole, and I don't have a lot of room here, so I'm not writing the whole thing. Okay, but I would cross out the H2CO3 would be down here. So my answer is that I also have 0.23 moles of K2CO3. Okay, so now I'm going to have to erase some, sorry. Okay, I can't keep all that there. Okay, so now that I have that, what do I do? Okay, now that I have that information. Okay, now the question says, how many grams? How do I get from moles to grams? Atomic weight. Okay, so if I figure up the weight of K2CO3, I'm going to have 2 times 39.1. Up, now we're at the 1. Plus, I have 1 carbon, 1 times 12.0. And I have 3 oxygens, 3 times 16.0. I'm adding these up so I can't go past the 10th place. I have 138.2 ammus, which means that we know if I have 0.23 moles of K2CO3, I know that means I have that 1 mole of K2CO3 is equal to 138.2 grams. I multiply it out. I only need 2 significant figures here. I have 4 here. I go with 2. So my answer is going to be 32 grams of K2CO3. Okay, if you watch this and you still have problems, I'll be glad to help you with another problem. Okay, thanks.